This video will discuss safeguards goals for uranium enrichment. Uranium-235 is specifically designated as a special fissionable material by the IAEA, and therefore any material containing uranium-235 requires safeguards. Uranium-238 is a designated source material because it can be used as a starting point for the production of plutonium, and so it also requires safeguards. To develop the goals for safeguards, the IAEA has created several material categories for the different material types based on their suitability to be converted into a nuclear weapon and the time it takes to make such a conversion. Low-enriched uranium is an indirect use material. Low-enriched fuel can be used to create plutonium via irradiation, but the low-enriched uranium itself requires further processing, such as enrichment, to produce HEU, and so can't be used directly to make a nuclear weapon. Naturally, HEU, or highly enriched uranium, is a direct use material because it requires no further processing. It can be directly employed to create a nuclear weapon. The concept of significant quantities has been covered numerous times throughout the NSSEP modules relating to safeguards. But just as a review, significant quantities represent the quantity of a certain material as determined by the IAEA that is considered sufficient to manufacture a nuclear explosive device. The IAEA has general overarching goals for nuclear safeguards. These are the timely detection of diversion of significant quantities of nuclear material from peaceful nuclear activities to the manufacture of nuclear weapons or of other nuclear explosive devices, or for purposes unknown, and deterrence of such diversion by the risk of early detection, and the detection of undeclared nuclear material and undeclared activities in a state. At uranium enrichment facilities, the detection goals would therefore be 1. To detect the diversion of 75 kilograms of uranium-235 in the form of depleted, natural, or low-enriched uranium within 1 year of possible diversion. 2. To detect the diversion of 25 kilograms of uranium-235 in the form of highly enriched uranium within 1 month of possible diversion. And 3. To detect possible misuse of the facility for undeclared nuclear activities. This includes production of undeclared HEU and LEU, and the production of LEU and HEU in excess to that declared. These goals lead us to certain verification objectives, which include verifying the presence or absence of special nuclear material. This is also known as the detection of gross defects, when no uranium or uranium-235 is found when it is expected. This is accomplished through physical inventory of the material and other nuclear material accountancy measures. Verifying the identity of the special nuclear material. In this case, the verification activities are focused on ensuring that all declared items are present. One method of verifying identity would be through comparing identification numbers on containers with the information supplied by the facility operator. Verifying the content of uranium. This would be the detection of partial defects, which could be in the form of a reduced uranium mass. In other words, less uranium than was expected, or a reduced uranium-235 content, a lower enrichment that was expected. There are many different methods of verifying the content of the uranium. There are both non-destructive assay techniques, mostly using detectors to determine isotopic concentration, and destructive assay techniques where material from the facility is collected and sent to the lab for analysis to determine uranium content or isotopic concentration. Detecting bias defects. A bias defect refers to an item or a batch that has been slightly falsified so that only a small fraction of the declared amount of material is missing. This occurs when the amount of diverted material is within the uncertainty of measurement. Basically, we need to monitor small differences between declared values and measurement values to ensure that states are not using the uncertainty thresholds to divert small amounts of material. And lastly, maintaining continuity of knowledge. This is accomplished through containment and surveillance measures.